Hey guys, and welcome back to a new video. In this video, we will actually deep dive into exception handling and cancellation mechanisms for coroutines. On the surface, coroutines are super simple, and especially if you just learn them and it feels like just async and await in JavaScript or so, then it seems super easy, a super great tool to actually use for asynchronous programming, and they are a really great tool to do that. But if you dive deeper into coroutines, there are actually a lot of traps you can step into. There are a lot of complications and a lot of things that are not trivial, like exception handling and cancellation mechanisms, which I will cover here. So it's not like just using a try and catch block. You can do a lot of things wrong if you do that. So I will now explain how you should catch your exception, how you should handle them in coroutines, how exception handling actually in general works for coroutines, and what you actually need to consider when your coroutines are cancelled or when you cancel your own coroutines. So first of all, how most people think exception handling works for coroutines. Let's say we have a coroutine here in lifecycle scope that we launch, and then we have a child coroutine here in which we could throw an exception. So far so good. Many people now think they can just use a try and catch block to catch that exception. So exception, and we could say we print caught exception E. If we now launch this and take a look in logcat, clear this, then you can see that exception was actually not caught. So it made our app crash, even though we actually used a try and catch block. So that's how exception handling in coroutines does not work. So how does it work? Well, to understand that, we first of all need to understand how coroutine scopes and coroutines in general work. So at the outside, we usually have such a coroutine scope like lifecycle scope, view model scope, or just your own custom scope. And we launch a coroutine inside of that scope. And then inside of that coroutine scope, we have the option to launch more of these so-called child coroutines, which would be this one here. And these two just run independently of each other. And now what happens if we throw an exception in here? So that could, for example, come from an API call, let's say use retrofit, and yeah, there is, for example, an HTTP exception. So your server replies with a 404 not found or so, and that would throw an exception from retrofit. And since that is usually executed in a coroutine, or you can at least do that, that would be a normal, typical thing where such an exception could occur. And now what happens with this exception? If it is not handled directly by using a try and catch block, and I don't mean such a try and catch block, I mean one directly in the coroutine where it's thrown, so in here, that would, however, work. If that is not the case, so if it's uncaught basically, what will happen is it will simply be propagated up these coroutines. So let's do it a little bit more, let's launch another one to make this even clearer. If we throw an exception in this child coroutine of this child coroutine, this exception would be propagated up to this coroutine first. It will see, okay, there's an exception. Let's propagate it up to the next one, which would be this one. It's still not handled here, so we will propagate it up to the next one. And here it actually reaches the outer coroutine and it's not handled. So at this point, our program will crash. And that's exactly the same what also happens with cancellations, because when a coroutine is canceled, it will throw a cancellation exception. A cancellation exception is not a bad one in the sense that it will make your program crash. It actually won't, because these are always handled or actually caught in coroutines. But these are still propagated up your coroutine tree kind of, so that all coroutines, like the parent coroutine, the child ones, and the child ones of the child ones, actually all know that a specific coroutine was cancelled. However, now we only covered the case that we use a launch. But if you know coroutines a little bit and maybe watch my basics playlist about that, then you know that there's also a different way to launch a coroutine, which is called async. Async will return a so-called deferred, like in comparison to launch, which will just return a job. Async will return a deferred. What's the difference? Well, launch is just used to do something. We don't expect launch to give us any result. However, with async, we expect that result. So let's say you do a network call and you are interested in that result, but you still want to execute that network call independently of another coroutine. Then you could use async and actually get that result using a wait. So for example, we could remove this and we could say val, string is equal to async. In here we could delay this block for like 500 milliseconds and then return our string that will be returned here in our async block. And that will be executed. However, if we then want the result of that async block, as you can see, if we see the string is now a deferred of type string, so it's not a string yet. If we want the result, we can say, for example, println string.await. So that's just important to understand because there are differences how exceptions are handled when it comes to launch versus async. So here, if we print this line, this await block would simply suspend this coroutine, like this launch block here, until that result is actually available, which would be after half a second. And the difference now how exception handling works for async in comparison to launch is that async will actually kind of throw the exception that it has accumulated when we call await. So let's say we would do a network call here, kind of simulate that, and that network call would throw an exception. Something like this. Then this wouldn't immediately make our program crash. It would only make it crash once we call await. While if we use launch, it will make our program crash as soon as we throw that exception. So if we now remove this await, relaunch this, you will notice something, that our program still crashes. So why is that? Even though we used async and I said that it will only throw or raise that exception when we actually call await on that defer that it returns. However, if we think about the mechanism how exceptions are propagated again, what will happen here is it will throw that exception, but since it's a child coroutine, it will propagate that up to the parent coroutine, which is this one. And what do we see here? It's a launch block. So again, since we have a launch block here, it will also handle that exception like any launch block. So it will immediately make our program crash if it's not handled. If, however, we also swap this out with async and we relaunch our app, take a look in Logcat, then you can see nothing will happen because we use two async blocks here. This exception is propagated up to this coroutine and to this coroutine, but since both these are async blocks, they won't immediately make our program crash. They will actually leave that up to the user. And with the user, I mean whoever actually calls await on these two asyncs. Or actually not on these two, this outer one should be enough. So if we now have a caller of that, let's say another lifecycle scope launch block. So imagine this will just be a deferred that comes from a library and that returns a result after doing some async stuff. And you now want to consume that deferred in a launch block and you say, okay, you have that deferred and you actually consume that here using deferred.await and we relaunch this, then it will crash again because now we actually called await here. It will kind of raise that exception. Since we again have the launch block, it will make our program crash since we don't handle this here with try and catch. So if you have a deferred, then you can handle the exceptions just by surrounding this with try and catch here. So if we catch this here, exception, for example, print this, then we relaunch this and it won't crash. It will just print the exception here as a warning log, but not as an actual error log and not as a crash. However, if you catch your exceptions like that, you are doing something wrong and not many people know about that. I will get into this later once we learned a little bit more about how coroutines work. So at the end of this video, I will talk about this mistake here, but definitely don't catch your exceptions in coroutines like that. Even though it works, there are things that can go wrong. But let's first of all think of a different way how we could also handle uncalled exceptions in coroutines. Like try and catch is of course one way of doing that, and that must be in the coroutine which throws that exception, or if you have an async one, as I said, you need to surround your await call with that. However, what we can also do is we can use a so-called coroutine exception handler. So we can specify a specific handler, which is a coroutine exception handler here, which gives us the coroutine context. So that just gives us information about the specific coroutine that threw that exception. We don't need that here. And we of course get the throwable. We could print this here, caught exception, and print the throwable. And if we now take this handler, we can install this into a coroutine that we launch. And it must be at the root coroutine where we install this. So the root coroutine would be this async block or this launch block here. Let me actually get rid of this async block and just get back to launch blocks here. We just have a lifecycle scope.launch, and here in parentheses we could pass this handler. And if we now throw an exception here and say error, and we launch our app, then we will see that it's suddenly not crashing anymore, but it prints we actually caught this exception. So that is a way how we can actually catch exceptions in coroutines that are propagated up. So even if this now comes from a child coroutine, which we would launch in here, where we throw this would get propagated up to this outer coroutine eventually. And if we then take a look, we still catch that exception. So it will basically just handle all uncaught exceptions that come from any type of child coroutine in a root coroutine. And it's also important to mention that this won't be called for cancellation exceptions. So if one of your coroutines here is cancelled, this block won't be fired because, as I said, it will only be handled for uncaught exceptions. However, cancellation exceptions in coroutines are handled by default because you don't want your app to crash because a coroutine was cancelled. And as a last thing before we get to the common trap and mistake that I mentioned here, I want to talk about two different scopes of coroutines that you can use in your apps that decide about how specific coroutine and child coroutines are cancelled. On the one hand, we have the normal coroutine scope, and on the other hand, we have the so-called supervisor scope. So I'm sure if you know the coroutine basics, you will have seen things like this, where you launch a coroutine scope, for example, in the main dispatcher, and you call that launch on that. And a very common question I get is, what's the difference between this and launching a coroutine in global scope? Well, with this coroutine scope builder, you can kind of create your very own coroutine scope on the one hand. But there are differences between different types of coroutine scopes, which determine how cancellation is handled in such a coroutine. Let's try to understand how this works with such a normal coroutine scope. If we have child coroutines, and let's say we delay this for 300 milliseconds, we save this in a job, so we could cancel it, for example. Or we don't need the job here, but let's say we delay this for 300 milliseconds and then we throw an exception. So then something goes wrong, whatever we're currently doing. And we say coroutine 1 failed. And then we have another independent coroutine of coroutine that is independent of this one, which would delay for 400 milliseconds, so which just takes a little bit longer than the other one, but that one succeeds. So when that finishes, we say coroutine 2 finished. If we now launch this, then this will probably be obvious what happens here. You can't see that for some reason. It actually crashed on my phone. Let's relaunch this. Yeah, now we can actually see the stack trace here. You can see coroutine 1 failed. And of course, if our app crashes, it won't execute our other one. That is pretty clear. However, what happens if we now install a coroutine exception handler, which we just did, and we say we caught an exception again, like this, and we install this handler into our coroutine scope. If we want to actually combine two coroutine contexts, such as this one, with the handler, we can simply use the plus operator to make sure we apply this here. If we now relaunch this, we will see we caught an exception. Our program didn't crash, our app didn't crash. However, we don't see that coroutine 2 actually finished. So what happened here? Because I said these two coroutine scopes are actually these two coroutines are running independently of each other. So why does this one seem to affect this one? And the reason behind that is that we used CoroutineScope. What CoroutineScope will do is, as soon as one coroutine fails, no matter if you handle that exception or not, it will cancel all its child coroutines and then also the whole scope. So the whole scope will be cancelled as soon as just one coroutine fails. And with failing, I mean that it throws an exception. So here we throw that exception, it is propagated up to this coroutine scope. It will see, okay, a coroutine failed, so it will cancel the whole scope and also all the other coroutines running in that launch block. And that is why this printline statement is actually never printed here in this case, even though we actually catch that exception. And that is now where we come to the other version of the coroutine scope, which I mentioned, which is the supervisor scope. We can directly apply that here inside of that launch block, call that supervisor scope, and put our two launch blocks in there. And if we now relaunch this, same thing as before, just that we now have that supervisor scope, you can see we caught that exception now, but we also get the log that our coroutine 2 finished. So the difference now is that with supervisor scope, if one coroutine in that scope here fails, throws an exception, that won't have any effect on the other coroutines like this one in that scope. So you can kind of group coroutines together and give them that behavior that they don't affect each other when they fail. In the same way, you could also group coroutines together to have that behavior that if one fails, then all should fail by simply using this CoroutineScope block here. And that's actually a very important difference, because sometimes in your apps, you need custom coroutine scopes. Because sometimes some components need their own or have their own custom lifetime, and you can define that custom lifetime by using a coroutine scope so that all the coroutines used in that component will be properly cancelled when it's not used anymore. For example, such a scope would be the viewModel scope. When the viewModel is cleared, then all the coroutines running in that viewModel will also be cleared. And to create such a custom scope, many people just use this coroutine scope here. So this builder, use some kind of dispatcher, and maybe not even an exception handler. And the big mistake and issue here is that if you do this for your own custom scope, then if one coroutine in your whole component fails, all others will fail, your coroutine scope will be cancelled, and once a scope is cancelled, you can't relaunch new coroutines in that. So imagine that would actually be the case for a viewModel scope. That would mean that as soon as one network call, for example, fails in a viewModel scope and throws an exception, then all the other coroutines in your viewModel will be cancelled. The whole viewModel scope will be also cancelled, and you can't launch new coroutines unless you recreate your whole viewModel. That's of course not what we want. And if we actually go to a viewModel and we have the viewModel scope here, where we can take a look into holding control and clicking on that, we will see that behind this viewModel scope, there is actually such a supervisor job. And that is combined with the main immediate dispatcher. But that's the important part here. That the viewModel scope is, of course, such a supervisor scope, because we don't want this behavior that if one coroutine fails, that all others will also fail and be cancelled. And the same is, of course, true for lifecycle scope. But it's just important to understand this. If you implement your own coroutine scopes, then usually these are supervisor scopes. But of course, it's dependent on the context. That doesn't mean that coroutine scope, this one here, is bad. It's just that you need to understand the difference. And if you want that behavior, that if one coroutine fails, all of them fail, for example, if these jobs are kind of related, and you usually want that, then you of course need to use the coroutine scope and not the supervisor scope. So far, so good. As a last thing, as I mentioned, I want to talk about the common issue I see people do when it comes to exception handling in coroutines. Let's get rid of this again, actually, this whole thing. And we again just launch, let's do lifecycle scope, launch a coroutine in that, and we launch a child coroutine in here. And let's say we do a network call here. We just simulate a network call which could come from retrofit. For example, you might want to catch HTTP exceptions if your network call failed, if it responded with a 404 or any other type of network error. So you say try and catch, and you catch these exceptions in here, which you could print here, and here you could just simulate making that call. However, if you now save that in a job and you cancel this after some time, let's say we delay this outer coroutine for 300 milliseconds, and then we cancel it because it could be that your user navigated away and the viewModel scope was cleared, which would cancel the coroutines in it, or any other reason basically. And here, after that launch block finished, we would write coroutine 1 finished. So this should actually only be called if that coroutine actually succeeded, because if it was cancelled, then we would get a cancellation exception, it would be propagated up to this one, and it would actually also make this one fail here. However, if we now launch this and take a look in Logcat, then you will see we get our cancellation exception here, but it still prints coroutine 1 finished. So that's weird. So even though we cancel this coroutine, this launch block here, after 300 milliseconds, it will still print this here. But shouldn't it actually not print this if the coroutine was cancelled before? And yeah, it should. Let's think about why this happens. And that is a very common mistake, as I said. What happens if this coroutine is cancelled? If it's cancelled, the current function that is suspending that specific coroutine, which in this case is delay, will throw a cancellation exception. But as you can see, since that delay is executed in a try and catch block, that cancellation exception would be eaten up by that try and catch block. Since we just catch general exceptions here, we would simply print that exception, that cancellation exception, which also happens here in logcat. But since it's now a caught exception, and since we kind of consumed that and eaten that up, it's not properly propagated up anymore. So this outer coroutine scope doesn't know that this child coroutine actually was cancelled. And that is why it will still print this log statement here. So let's think about how we can fix this. On the one hand, of course, if let's say that is a retrofitted call again that gets cancelled, you could do this by specifically catching specific exceptions, like an HTTP exception here, which we don't have here. Let's just take that one instead. Then that would of course not be called here for cancellation exceptions because you only catch these specific exceptions. So if we now relaunch this, take a look in logcat, then you can see it's cancelled and we don't see our coroutine1 finished log. Another option which you could apply here is, if you want to catch general exceptions, is that you check if that exception is a cancellation exception. And if so, you would simply rethrow that exception. So in that case, you throw it again, and that would also notify the parent scopes. So if we now relaunch this, we will see that it will just work the same as before. But that is a thing that not many people talk about, but it can really mess up your coroutines, and it can lead to wasted resources because your coroutine that is actually cancelled will still do some things and will still consume some resources. And that is really everything but obvious. So that was really a deep dive into coroutines, and I hope that really helped some of you to understand them on a deeper level, because I think the Kotlin docs are very cryptic on that, so it's not obvious if you just read through these. I hope that made it a little bit more understandable here. And if you actually want to take that to the next level and learn about flows, then I have the perfect playlist here for you. So definitely check that one out.